Welcome to the session on cloud, the ultimate enabler of big data, AI, IoT, smart cities, and many other technologies which are evolving. We will go through the basics of all of these, and then we will understand how this is going to be in the industry for the next 20, 30 years. Cloud is the basic underlying paradigm for all of these new technologies. So we'll start with the basics, the cloud basics, discuss about IoT, big data, artificial intelligence in its new form, smart cities, and then we'll see how all of these can be deployed on the cloud and how these are going to affect the industry and us as the people working in the industry. What are the areas that we can contribute, which areas are going to be promising in the future, and all of that. So let's take a quick jump into defining what is cloud computing. So cloud computing has been there for some time, and the term cloud itself is a metaphor for all of these connectivity and all of that, the new form of service and all of that made this term cloud pop up sometime in 2005. And after that, it has been around. We do not know who proposed the name, but it has been there for some time now. So the NIST, which is the National Institute of Standards and Technology, they have defined the cloud computing, which is nothing but a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable resources, which can be servers, storage, network, applications, etc., and can be rapidly provisioned and deprovisioned with minimal management effort from either side. So that's the basic definition of cloud computing. So what are the characteristics of cloud computing and how it differs from other models is basically that it has to have these 5 specific characteristics. It should have on-demand self-service, which means that people can enable new services, can spin virtual machines, can view applications, whatever, on demand with no intervention or no human intervention rather, and it is all automatic. So that is what it means by on-demand self-service. All of the provisioning, background, housekeeping, maintenance, everything is automatic. Second is that, of course, it needs to have a continuous, seamless network access throughout the entire end-to-end connectivity. So from the area where it is being served to the end customer, there has to be a complete network and good network access, and that's given. Third is the resource pooling. Now, where my storage is, where my computer is, where my applications are, how they are connected, and all of that is completely independent and it's completely transparent to the users who are using it. Number 4 is rapid elasticity. What by this we mean is that whenever there's a crunch or there is a burst in use of the particular application, then automatically resources will be picked up from the places where there is less usage, and it would immediately help to get this application scaled up. And when the demand goes down, it will be automatically brought down. So that is what it means by rapid elasticity. And the final one is measured service. All of these services are measured at a very granular level. So you can have services which can be per second, per minute, per hours, and so on. Because earlier what we had is that the metering or the billing thing was not there. People used to own these devices, own the computers, own the data centers, and this kind of metering was not necessary. Now with the advent of this kind of new model where you pay as you go, measured service is one of the main criteria for doing business and realizing the revenue. So these are the 5 characteristics of the cloud computing. So cloud computing, we have what is known as the deployment models and the service models. So deployment models are basically 3 deployment models. So you have public cloud, where you have the service provider is giving access to any of the people from anywhere, and that is what is known as the public cloud. Second is known as the private cloud, where if you are owning a private cloud, you will be having access to that, and nobody else can be having access to your particular private cloud. That is what it meant by private cloud. Private cloud can be hosted in your premises, in your office, in your data center, in your co-located data center, or it can also be located in a cloud service provider's premises, where he can reserve a particular service, a computing pool for you, and then nobody has access to that, right? So that is also another model of private cloud. The third is very simple. When you combine the private with public, that becomes the hybrid cloud. How it is done? For example, you are owning a private cloud, and suddenly you find that you are running out of resources. For example, you're running, say, a particular content media. For example, you're streaming some, say, a live cricket match, and suddenly you find the hits on your servers are going like anything on your private cloud. Then what you do, you try to bring in resources from a public cloud. And how you do that? You run your application on the public cloud and connect these two together. That's how you get a hybrid cloud. So that's an example. You can have other examples, like you can go for banking, any sector, any industry that you're running. If you're having a crunch, then you can go to the public cloud, hire the services for a certain duration, run your application on that. The main crux is that for private and public to become a hybrid cloud is that you need to be sharing data. So what that means is that the private cloud will be having the same application on the public cloud, and you'll be sharing data between these two applications, public and private. That is what makes a hybrid cloud. The third is the service models. You have the three basic service models, which is infrastructure as a service, platform as a service, and software as a service. The complexity goes from bottom to top, and the ease of operation is from top to down. So what this means is that you have infrastructure service, where you give compute as a service, storage as a service, and now you have the new thing, which is known as network as a service. So you have three pieces of infrastructure as a service. Next is the platform as a service. So infrastructure gives you the bare minimum infrastructure, and on top of that, you build a platform. So what is a platform? Platform is an operating system along with some development or some other tools which will help to develop new applications which can be put on the cloud, right? So this is a development kind of platform where you can develop things, you can test things, and then the final stage is software as a service. Once this is developed, it can be all those, the development tools, the platforms, and all of that can be removed, and then you just have the application which can be run on the infrastructure. So that will become a software as a service. For example, the Google Mail, Facebook, all of these are software as a services. They are being offered from a cloud platform, and all of these are applications which are hosted on the cloud, on infrastructure, right? So these are the three service models. This picture clearly explains the three different types of the service model. So if you look at the bottom, you have the infrastructure service, and it supports the platform as a service. And once the platform as a service has been developed by the developers, it goes as a software as a service, which can be consumed by the end user. So all of these three, if you look at the left-hand side, all of these three have the vendors who are supporting these. So infrastructure service is also supported by a vendor, platform as a service is also supported by a vendor, and the software as a service is also supported by a vendor. So there is a need for professionals, for cloud professionals, from a data center perspective. There is a need for developer on these particular platforms. There is a need for maintaining the software as a service on a regular basis. So all of these, there is a requirement in the industry, a huge requirement in the industry which is coming up from a resource perspective. So all of these areas are going to stay for the next 10 to 30 years. That is what the prediction is. But definitely it's going to be like 20 years. It's going to be there. All right. So let's see at the predictions. So what are the predictions? The worldwide public cloud predictions is like $383 billion. Can you believe it? In just a couple of years, we have a prediction of $383 billion currently coming in from Gartner, which has been very new, and it's like February 2017. It's very new prediction, and we are hitting those numbers. So that is the whole thing. So if you look on the left-hand side, you have a gamut of services for which resources are required, for which people are required to provide these kind of services. So what you have, if you look at the bottom, which are the highest, the cloud advertising, this is one of the areas which is very, very growing very fast. Then you have, of course, the default, the infrastructure as a service, in which you have the bare metal services, then you have the compute as a service, storage as a service, and now the new services which are coming up are DR as a service, disaster recovery as a service, backup as a service. Okay, and then you have coming, what are the new things called as container cloud. So all those new things are coming up, and this is just a manifestation of all of these, which are people are thinking are helping them to optimize, to increase performance, availability from a security perspective. All of that comes in. Then you have cloud management and security services. This is also a big chunk where people are with those specific skills are required to deliver these services. All right, so we quickly go, because of the time crunch, we'll quickly go into the various areas which are very hot for the cloud computing platform. And one of these is definitely the Internet of Things. So Internet of Things has been nothing new. It has been there for some time. This has been coined by an entrepreneur in UK in 2007. And that's what he called Internet of Things. So what we have is that we have the Internet, and then we have the separate devices which are connected to the Internet. So that is how the simple thing is called Internet of Things. Earlier it was known as machine to machine, and with the advent of analytics and the high connectivity between these devices, the new term has been coined as Internet of Things. So this slide explains what is the difference. So earlier what we had was the machine to machine. Machine to machine has been there since like ages. It has been there since 1960s. So you have a machine, an end device, a tech equipment which is talking to the main application through a network, right? So that was what is known as the machine to machine. So if you look at the three layers, you have the last layer is of course the device layer, which you have the sensors, the devices, and all of that will communicate. It also have some communication mechanism which will go and to talk to the main control plane. So the main control plane again aggregates all of that and takes it to the application. So this is what was there in traditional machine to machine. Now what you see in Internet of Things is that not only, if you look at the last layer, which is the devices layer, not only that these devices are communicating to the aggregation or the control plane, it's also communicating amongst themselves. So that is the change. This is what is the Internet of Things. So this is how the devices are communicating and talking to each other, as well as talking to the control plane. So this is where the difference lies. And here from an industry perspective, the requirement is that you need to either be a device specialist. For example, all the wearable devices which are coming in. For example, you have those pedometers for heartbeat monitorings, for all kind of devices, even car communications, car navigation, car control. Then you have machine control for airplanes, all of that. So there are n number of devices which are there. So there's an opportunity to become a device specialist, in which you have sensors, and there has to be a communication mechanism. So this is what is the devices. There's a huge requirement there. Then you have requirement in the control and the application layers, where how are you aggregating the data which is coming from these devices, which will you ignore. For example, if you look at the smart grid, which is an extension of the regular electricity network, right? So smart grid, you have smart metering devices, AMI, automatic metering infrastructure, and how these are automatically providing data to the utility providers, how the billing is being done, how you're being monitored, and all of that. So this is again an example of IoT, right? So this is how other things will keep on evolving over a period of time, when people get more understanding, and things are even like the computer is going faster every time. The storage, if you look at the storage now, all the flash disks are coming in, the spindle disks are going away, the space is very small, performance very high. So all of those things are going to happen. So even look at your mobile devices. Mobile devices got a gamut of sensors, So it has got an accelerometer, it's got a camera, it has got a GPS, it's got a proximity sensor, it's got an infrared, all of that. So you can use your mobile device also as one of the sensors, right? Like Google is doing it. So if you look at the Google Maps, so how Google is telling you that this traffic, there's a road. If you go from point A to point B, it shows you by three colors. It shows you by yellow, by blue, by orange, and then red. It shows you the traffic in 3 different colors. So how does it get colors when it doesn't have any sensors on the road? There's nobody there, right? So how does it do that? It does that by your own mobile device. So when you are traveling on the road, so the Google tracks your position. That's again a privacy issue, but that's a different thing. Google is tracking you on your mobile device and taking the information on your speed, on the wait times. And based on that, based on heuristics and artificial intelligence, it's predicting the next leg of your journey, which can be yellow or a red, right? So that is how things are being done. All right, so again, this chart shows there is again a huge information which can be decoded from all of these devices, and you can have location-based services, you can have security, you can give information, and all of that. So huge chance for people as well as for the business. This chart shows that how much of data is being generated in 60 seconds. You know. So if you look at the say blog posts, if you look at the videos, look at the music which has been loaded, look at the Skype calls, look at the various documents, all of that, right? The next chart also shows you in the different applications again in next 60 seconds. For example, the videos, the camera uploads, the LinkedIn messages, the WhatsApp messages, all of that, which are done in 60 seconds. I mean, see the amount of data which is being generated, the huge amount of data being generated, and what you can do with this data. So that's the crux. So data is a new economy, you know. So anybody who's got data, if you look at the way India is going, if you look at the Digital India, the initiative which has been taken by the government since 2015. So the idea is to convert all of the cash transactions. I mean, reduce the cash transactions and make it digital. So when it's been digital, if you look at a bank account, you're looking at the figure in the bank balance, right? It is nothing but data. If you think of that, it's nothing but data. You don't have it in your hands. It's just data. So look at the amount of data being generated. Sorry. So this brings us to the next big thing, which is the big data. All right. So big data has been there for some time, and the general idea of big data is nothing but huge data, right? So the term big data was first used in an IEEE paper on visualization, and it is defined the problem of big data and how the working of large volumes in way back in 1997. So that is where it was defined, and then there were 3 parameters for big data, which was introduced from Gartner in 2001, which talked about the volume, variety, and the velocity. Then again, there was an evolution, and somebody from Google, they did something known as the MapReduce in 2004, and that's how this got introduced along with the big data. And then, of course, you have the famous Hadoop and the HDFS, which came in 2005, and this was being credited to the Yahoo people who have developed these, right? So this is just a small evolution on the big data stuff. We'll move on to the next thing. So what are the V's in the big data? So we talked about the 3 V's, the volume, velocity, and variety. And then of course, you have the 4th one, which is the veracity. So, so the transactional and application data, the volume is structured and it's very high. And then you have the machine data. Again, it's coming from, for example, the IoT. The machine data, the velocity is very high. You're getting n number of data inputs coming in from various devices. For example, if all of the cars, the automobile that you are using, any car you talk about has got an ECU, electronic control unit. And what it does, it is generating data at a tremendous speed. It's taking inputs from various sensors. It is taking from the engine data. There are about 35, any normal car has got about 35 engine parameters. And then on top of that, it runs all of that continuously in a continuous mode to check the performance of the engine and all of that. So machine data is being generated at very high speed, and it is semi-structured, and it has to be captured properly for analysis. Then you have the social data, which is completely unstructured, and that is how the big data is a combination of structured as well as unstructured data, right? So this is where the whole thing comes in, and then you have a huge volume here. So you not only have a variety, you have videos, pictures, songs, movies, text, whatnot, and then you have the volume, the huge volume. The fourth piece is the veracity, right? So what does the English word veracity mean? Veracity means is that the proof that the data is what you're sending is what you're receiving. That is what the veracity means. So the data integrity and security is an important component of veracity, and this is how all the 4 V's in big data are related. So this is, and the fifth value is, of course, the value. The fifth V is the value. So all of this is value, and from here, you're making business. So for example, from a social data engineering, you can depict a particular market trend. You can depict what is known as the sentiment analysis, and you can see whether the product is good or bad, and you can influence people on that, right? So if you look at the transactional application data, for example, you're doing shopping on some website, all of the data is being stored, and then you correlate that with the actual social data. We'll get a lot of input, a lot of insight into what that particular person is trying to do or would try to purchase in the next near future. So all of that is a part of big data, and analytics is one of the important characteristics of big data. So here, what is required from an industry perspective is that we require people who have analytics skills, people who are good in databases. Now that you don't have a single database, most of this what is being used as a data lake. So what is a data lake is a combination of various databases. It can be relational database, it can be a key value database, it can be a column database. You have a lot of databases like you have MongoDB, Redis, all of that. So all of these are used for different purposes, and this is how the whole thing works. So you have different databases, and each of them have their own requirements, and it has got its own characteristics. So all of these together will form the big data, and we require people on that. So you require database specialists, you require people with strong analytical backgrounds who can write codes to do quick analysis, and there how the artificial intelligence again comes in. So these are all interrelated, and all of these run on a cloud platform. So this has to be very clear, because all of these you cannot run them independently. They are running on a cloud platform, because the cloud platform has got a pay-per-use model. Now people are moving out from the capex model, where they are putting money into getting their own servers and storage. What they're doing is they're just hiring from the various providers, and these are the providers who would provide opportunities for people from the industry to join and to contribute. All right, so this is just another view of the big data. I'll move on to the next one, which is the artificial intelligence, right? So artificial intelligence is something which has been there for more than roughly like 70, 80 years now. So artificial intelligence and the cognitive together, what we know as the cognitive computing, is coming in a new form, and it's still evolving. So you have one component of the artificial intelligence. Artificial intelligence is a huge umbrella. Under that, you have machine learning, and a subset of machine learning is known as the deep learning or neural nets. So there has been a recent interest in neural nets because of the increase in the computing power of the GPUs, the graphics processing unit. So that has been used for performing this deep learning applications which are being there. So for example, there are many vendors, but primarily the NVIDIA is number one in developing the GPUs, and these GPUs are being used in combination with the CPU to deliver deep learning solutions. So what happens in deep learning is that you give a particular input, and you expect the output coming out automatically. So that is how the whole thing works. For example, I take a picture of a cat, and the machine should automatically say that this is a cat without training it even. So that is the idea. So how the training works, how the unsupervised learning, supervised learning, and all of that, how the whole database is generated, how the data points are generated, and how this whole optimization works, coming out to a particular conclusion. That is what is the whole crux of the deep learning. So this is what the industry is moving towards. So again, where the application is, the application for deep learning is to get insights into trillions and operations which are going on. For example, from a social engineering, from social network, from the transactional network. So you're doing shopping in a particular site. So if you look at the Amazon site, so for example, if you shop for something, then it says the people who have bought this have also bought such and such things, right? So that is the analysis or the insight which you get from these kind of solutions. So they are using AI. Amazon is using AI for this kind of inference, data inferencing. Quickly moving on to the smart city. Smart cities is again basically an umbrella. You have more than 150, 160 use cases of particular smart city. So smart city in general is just a definition which says that it uses the generic, it's very generic, it uses the communication information technologies in an intelligent, efficient use of these resources, right? So the origin of smart cities this came out, but and IBM has been one of the pioneers in developing smart cities way back in 2008 with Brazil, one of the key landmarks for the Rio. It's called Intelligent Operation System, IOC. It started way back in 2008 and has been quite successful. So there are many places where the smart cities. Also in India, you have a lot of smart cities activities going on with the government's initiative to have 100 smart cities. So smart cities is basically how are you going to use efficiently the various things the idea is to basically to bring down the consumption of electricity, greenhouse gases, pollution, and to have an efficient and effective social life. So that's the initiative of a smart city, right? So for example, now if you look at the public transport, for example, so if you look at metros, so the metro as a train, a rail service, not a metro city, but a train. So metro in India has been quite successful. And earlier the ticketing system was very cumbersome. Then we came up with a RFID based machine ticketing system. RFID is again nothing but an IoT, right? So it's machine to machine. So you have a chip, you put some money into that chip, and then when you touch the chip near the RFID device, the gate opens for you. Similarly, when you get out from the train, the system automatically computes the travel, the distance where you got in and where you got out, and based on that, you will be billed. So this is an example of IoT, and this IoT again, you can do analytics on that, and this becomes a part of the smart city. So this is how the whole thing works. And this card, if in India it is only for the metros, but this smart chip in abroad for example in United Kingdom, that smart city, it's a company called Oyster. They use this chip for not only for train travel but for bus commute, for the DLR and all of that. So this can be extended to all of it. You can travel with the same concept on the buses, on various transports, or even on railways, for example. That is what the India government is trying to do. All right, so this is about smart cities. I discussed all of this okay, still have some time. So, so smart cities basically ensure the economic welfare and security of the citizens. That's the main goal for smart cities, and that's how the whole governments are looking at the smart cities initiative. Okay, so I talked about all of these and how all of these are connected to the cloud. So here's the whole thing. How are you joining all of these to cloud, and how it is going to help understanding these technologies into getting into new areas of interest in the industry, how to progress your career growth, all of these areas. So first, you have to understand the basics of what all of these things are, and then take step by step to educate yourself, to enhance the knowledge in that particular area, and take it up to your particular liking, and then you can contribute to the industry and take your career forward. So all of these things that we talked about, anything like right from the cloud to all of the topics that we covered, the IoT, the AI, the big data, smart cities, all of these require a particular architecture, right? So you need to have idea over the architecture, how the whole thing is constructed. So what is known as, from an architecture perspective, what is known as the CCRA, the Cloud Computing Reference Architecture. All of these different technologies that I talked about is basically going to run on cloud. So you need to understand the cloud computing reference architecture first, and then all of the use cases which are on the right hand side of the screen if you look at the use cases. So what happens is that architecture is nothing but a pattern or a schematic of things, how you're going to deliver that. For example, if you want to build a house, you need to have a schematic, right? So what I can do, I can have already a schematic for a 10-floor house, and then say that this is how the house layout looks like. Then you say, no, I want only 4 floors or 5 floors. Okay, so we can cut down that architecture according to your requirement. That is how the whole thing works. You have a pattern, a template, or a boilerplate based on which you can develop your own use case. So if you look at the cloud use cases, there are many use cases. One of the most important one is the DevOps. The DevOps is one of this very catching fast in the industry, and people are looking at the benefits of these DevOps applications. So what happens in DevOps is that you have the development and operations joined hand in hand. So earlier, what you used to have is in the traditional way, what you used to have a development environment, then you used to have a QA, then you used to have a UAT, and then you have to have production. Okay, so 3 or 4 environments is what people used to have. Now, what is happening is that this DevOps, the development environment usually has to be, used to be like 10% of the capacity of the production. Okay, the main crux was the QA. QA used to take about 30 or 40% of the production, and that too, it could not get the actual full data, full load testing could not be done on the QA. So that was a huge investment from any industry, from any company, and that is how the whole thing was. And the usage was like 10% or 15% of the entire lifetime. So there's a huge amount of investment going in, but there is no output. So with the advent of cloud computing, what happened was that, so you could provision rapidly a development environment. You can spin off a copy of the production into the cloud environment and run your QA on that. And once your QA is complete, take the results and then release the resources. So that was very good, and that is how the whole thing worked. So people could, instead of setting up, if you look at how you're setting up a QA, it just take like months to set up a QA environment. But in case of cloud, it just takes a couple of days or even a couple of hours to set up a complete QA environment for a full-fledged company, right? So this is one of the very, very interesting areas, and a lot of resources are required in this domain. So you need to understand the cloud, the architecture, and how the whole thing works, how the images are handled, image management, operations, and all of that. So you need to understand all of those components and be part of the DevOps. Then one of the important thing is the web applications, e-commerce, mobile applications, independent software vendors, enterprise, private clouds, and then high performance computing. So artificial intelligence is also within one of the areas of high performance computing that the cloud provides. After this, I'm going to show you how exactly an architecture of IoT, for example, is done, and then we can open up for discussion. So this I spoke to this about about why we require the cloud custom reference architecture. This is required because this enables the customers to understand the unique features and advantages of cloud computing. It bridges the gap between the actual requirement and the offerings which are done by the provider, by the cloud service provider. It gives practical guidance to the consumer or the customer as to how the business applications can be developed. He can think in a different way to come up with an innovative application which can be run on the cloud quite economically, right? And of course, it saves time, effort, and money, and the productivity is quite high. This is how the whole cloud customer reference architectures are developed, and this is part with the International Standards Organization, and it is part of the cloud computing international standard for cloud computing reference architecture. There are n number of reference architectures in the in this domain in the standards in the International Standards Organization, and it has been continuously being refined. I'll show you one of these. So this is one of the cloud customer reference architecture for IoT. Okay, so this has been taken. The source is basically the Cloud Standards Customer Council. You can also be a part of the. It's an open community. You can be part of this. So if you look at the architecture for the IoT, you can see the various amount of things which are there. So you have the IoT user, then you have, of course, the end application, and how the end application communicates with the various different components of this are clearly shown in this architecture, right? So one piece, you have the enterprise network, then you have the cloud service provider, how the cloud service provider, various entities in the cloud service provider, then you have the public network, which is the communication transport network, and then you have the proximity network, which is the aggregating network which you saw before, and then you have the actual IoT user and the application that supports the IoT user. This is how the entire chain for the IoT looks from a cloud perspective, cloud computing perspective, which is also, there is an underlying layer of security, and then you have an underlying layer of IoT governance. So governance is very much required with all of these architectures, right? Security and governance will be there in almost all the architectures, not almost, but every architecture will be there. If you have any questions, you can reach out to this particular telephone number and the site. And of course, if there are any questions, you can ask on the email as well. All right, then, good luck, all of you. And if there are any questions, you can again reach out to these contact details which have been shared. Thank you.